Today we're going to be talking about differential equations. An equation involving a derivative is called a differential equation, and the order of a differential equation is the order of the highest derivative involved in the equation. So an example of that would be dy dx. We know that that means derivative with respect to x. Say that equals 4x squared minus 3x plus 2. Okay? The order of that is the order of the highest derivative, so our order would be a first order because this is the first derivative. Now, when we're talking about, say, a second derivative, which sometimes we're going to see, that would be, our order of that one would be a second order derivative, because differential equation, I should say, because our derivative is the second derivative. So our first example, find all functions y that satisfy this equation. So what I first want you guys to do is, I'm going to rewrite the equation. What we're going to do is we're going to separate the variables, meaning when I take the integral, I need to know what variable I'm taking the integral of this right-hand side with. So I'm going to multiply both sides by dx. So therefore, I'm going to have dy on the left side equals 3x squared plus the cosine x times dx. That's called separation of variables. We're actually going to be doing more of that when we get into a later chapter. Now, take your integral. When I take the integral of the left side, we get y. When we take the integral of the right side, we get x cubed plus the sine of x plus c. Don't forget your plus c. They don't give me an initial condition. Sometimes they might say that y sub 4 is equal to 7. That means that the point 4, 7 is on our graph, and then we'd have to solve for c. And we're actually going to do an example of that next. Okay? But this would be our answer because they don't give us any initial condition. Our next example, again, another first order differential equation. Okay. What we're going to do here again, I'm going to multiply both sides by dx so that we end up with dy equals e to the 2x minus 3x dx. Now I'm going to take the integral of both sides. Integral of the left side is y. Now looking at the right side. What function's derivative is e to the 2x? Well, I know it's going to involve e to the 2x. But when I take the derivative of e to the 2x, I have that chain rule of our exponent, the 2x. So I need to incorporate the 1/2 in there. Because when I take the derivative of 1/2 e to the 2x, we have, when I take the derivative of that, that's 1/2 times by e to the 2x times by the derivative of the exponent, which is 2. Therefore, the 1/2 and the 2 cancel to get me this e to the 2x that's sitting right there. And then we have our next term, which is 3/2 x squared plus c. Now they give me an initial point. They give me a point that passes through 1/2. So plug in those values. Plug in 1/2 for y equals 1/2 e to the 2 times 1 minus 3/2 times 1 squared plus c. So solving this, we get 1/2 equals e squared over 2 minus 3/2 plus c. So I add the 3/2 over, and I get 2. I subtract the e squared over 2. So our final answer is going to be the equation y equals 1/2 e to the 2x minus 3/2 x squared minus our, or I'm sorry, plus our c plus 2 minus e squared over 2. So that's our final answer. Our next example. Notice now we have a second order differential equation. So when I take the integral, the derivative or the integral of the second derivative is your first derivative. Now when I take the integral of this right side, we get x squared plus c. Now, what I need to do is I need to keep in mind that right here I have an initial condition. I have that the derivative at x equals 1, y prime is equal to 1. So I plug that in. And we get c to equal 0. So we have now our first derivative. C is equal to 0, so I don't need to add anything in. Now what I'm going to do, I'm going to separate my variables. Now I'm going to take my integral, and we have y equals 1/3 x cubed plus c. Now I'm going to plug in my initial condition that's right here. Okay, so I know that y equals 2, x is equal to 1, so therefore c ends up equaling 5/3. So our end answer is y equals 1/3 x cubed plus 5/3. And that's all we have for today, a nice short video for you guys. Please make sure your lesson summary is submitted on time.